Hello everyone, welcome to Moon Kids. So today we'll be working on one important topic which is delta table and delta logs. Now how these delta log help us to find out what operations are done on delta table and what are delta logs basically used for. Let's find out. I am in data science and engineering personas. We have three personas here: machine learning, SQL, data science, engineering. Let's find out our compute instance is up and running. Good. And okay, before moving ahead, let me share some information about the channel. So this is for playlist for Python for beginners. This is for advanced topic, and this is for Databricks. This is the one which we are creating a new video for. So it has few videos based on Databricks introduction, integrations with Git, and managed versus external tables. So if I will share this link with you, if you wish to find out more about Databricks, you can. Now let's move ahead with one of our Jupyter notebook. Okay, so yeah, before moving this one, please try look at this option of data browse DBFS. This is quite needed over here. If you do not have this button enabled, so what you have to do is you go to admin settings, go to workspace settings, under under advanced, you will have DBFS file browser. This is by default disabled. So just enable it and refresh this session. So you will get this button of browse DBFS. So this is quite needed to navigate to the place where we have all those files as well as the delta log available. Now going back to our Jupyter notebook. So in this one, we will be creating delta table. We'll find out whether the delta table directory exists or not and how the logs look like. Okay, so this is a dbutils command just to find out how if we have some tables information or if we have some files information in our DBFS. This is just to explore information about our DBFS file storage. If you want to find out what exists in your folders over here, this is one way. Second is by using dbfs command. So if I want to see what exists in my CSV folder, I can use this command, execute it, find out the files over here in this folder. Now see here, what we are doing is we are creating a delta table. We are now defining a delta name over here, and but we're just creating a table. By default, when you create a table, it becomes a delta table. Now if you have seen one of my videos over here, which I'll share you the link, which is managed versus external. So if we are using location here, we are actually creating an external table, not the managed one. Now, first of all, find out in file store tables, do we have this table or folder or not, which is students delta learning. File store tables, students delta learning. I don't have it. Okay, so let's create one. So I'm going to create this table. Now see what will happen. Just I'll navigate these sessions over here to show you what happens when these commands execute successfully. Now, this folder should be created in the file storage. So if I go file store table students learning, so if I remove this CSV over here, there should be a one folder with this name, which is students delta learning, Going back in this place, let me refresh tables and students table learning is available. Now delta learning, if I click this one, you'll find a delta log is already created over here. Now this is a folder which will have the logging. Now this JSON just tells us that the table has been created. There is no other files in this folder. If you see here, files, the location is file store tables student delta learning, which is the name of our table. So when we created this table, this delta underscore delta log file folder got created, and under this folder there are these files. These files are the ones which are tracking the records of delta tables. We'll take this will show you that which particular records are the latest one, what happens when an insert, update, or delete operations are performed. Now let's find out this is 001. If I just copy the path here, if I go back, let me find out. Let's see, let's read this file, what it says. So we have a file of JSON. So how we have to read a file is select star from JSON. Okay, now let's read this file. Now this is the way you can read the file directly. You don't have to create a table or a view. If it is a JSON file, just write JSON dot then the file name path, and this will this information. I mean, you can directly query the file, which I want to tell that you don't have to create any table or view to find the contents. Now here, if you see what exactly has happened is this particular commit information is there that the table has been created. Create or replace table operation has been executed and the table has been created over here. Nothing else is done. Let's go back to our commands. Now these ones again, db utils, just to see the folder exists or not. Yes, the folder exists. Let me use this name over here also to find out that we have this folder. We don't have any file at the moment, delta log, but we have a folder delta log, which is this one. These are the files we have. This file says only that the table has been created and nothing else. Moving ahead, we will now insert three records. We will update one record, then we will delete a record, and we'll find out what happens over here. Now, what will happen is that under this one, there is a Parquet file created for each record. If I trigger this one, then a new Parquet file will be created and a new JSON and CSV file will be created, which will give us the information that a new record has been inserted. Now, let's go there. I'm going to execute. So it has been inserted. Let's find out what will happen there. I'm going to Delta learning table. Now if you see here, what happens is that a new record, which is a Parquet file, has been created. Now this is Parquet file contains this particular record what we have inserted. Now if you see here one.json, now new file has been created which refers that the new record has been updated. Now if I see a one.json, what exactly one.json has, let's find out. Now it says a data insertion has been made. If you see here, a record has been added with ID 111. Now going back to over here, this is a Parquet file which has this record. Let's insert another record. Now here we are going to insert another record which is ID of 222. Now what will happen? A new Parquet file will be created over here and a 2.json will be created over here. Let's find out. Let's go back. Delta learning. A new file gets created over there. Now a 2.json. So there are two records, two Parquet files and 0, 1 and 2, 3 JSON files. 0, 1 was only for to tell that the table has been created. For 1 and 2 are these records. Going back again, let's find out what data we have. Okay, let's insert one of the record and then we will find out. Now this is the last record we are inserting. Now we'll come back over here. When we refresh, there will be one Parquet file created over here and 3.json will be available over here. Let's refresh. Now see the three files have been created and 3.json. Now if I see the content of 3.json, then you will find out a new record has been created with the ID of 333. Let's refresh this one. Let's see the record. The 333 ID has been updated. So now if you see here, these JSON files are keeping a track of everything what is being inserted in the table. Now what will happen if we update or delete a record? When we update or delete a record, then also Parquet files In update, a new record will be created. Delete, no new record will be created, but in this particular log file, that will be marked as deletion. Let's find out. Now I'm back to the node. So here what I'm doing is I am updating the table and setting the name of Munish where the ID is 333. Let's trigger this one. Now also let's find out how our table looks like. Select star from. So we got three records. We have updated 333 with Amy Smith 3 with Manish. Now let's find out over here. A new record will be created over here and a new 4.json will be created. Let's find out. Let's refresh this data. Now if you see here, a new record has been created, which was for update, and 4.json has been created, which is keeping a track of that the data has been updated. Now if I come over here, go back to our JSON select command, if I give 4 here, which I believe it was 4, yeah, it is 4. Now if you see here, it is a data change operation. Data change happens. See, 333 data has been changed with the name of Munish now. So these are the log files which keep track of everything what is happening over here. It will mark as, a new record has been added and the record has been removed, which we have not done so far. We will do that. Removed and then updated. So if you find here, let me go back again what we have done so far. We have created a table with the name of students delta log. So at the time of table creation, only delta log file folder was created and this 000 JSON was created, which was keeping a track of the table was created and now no entries were created over there. So what will happen now is that when we inserted three records here, and the three records became a part of these Parquet files, for one Parquet file for each record, and then we updated the table and then a new Parquet file created for the updation record, and the latest JSON file keeps track of everything what's going on. Now what happens is when we remove this any entry from here. Now if we remove the last record from students delta learning, so what will happen is as we have removed the record, so there is no point of creating a new Parquet file because the record has been removed. But a new JSON file needs to be there, which will keep track of the thing that a record has been removed. Let's refresh it. We'll refresh this part. Now if you see here, still there are four files, there is no fifth file, but a fifth.json has been created, which is keeping a record that the one record has been removed. Now let's go to select star command, which was reading the JSON, and write 5.json here. Now if you see here, the data change has happened and a record has been removed. So if you see here, every action what is happening on the table is being recorded over here. So the latest file will always have the record of what has happened, and these files are the one which has the actual records. So if you see here with this one, a record has been removed with this timestamp, and these are the information over here about the record. So this is quite important to know how things works in Delta table. For Delta table, every record goes in a Parquet file, and every action has a record, a JSON file, which has the detail of that action. So what has happened is we created three records. When we inserted one record three times, then the three records were created over here, three Parquet files. When we updated that table, then a new Parquet file was generated, but when we deleted the record, there is no Parquet file generated, but the log file was created, which was this one, which keeps a track of that the record has been removed. Now, if we see now, let's find out the history of this table, what has happened so far. Now, if you see, this is quite interesting command, which is like if I just removed history over here, it will only show me the information about the columns. If I use extended here, then it will give me more information about what is the catalog, what is the database we have, and do we have, is this an external table or internal table? So this is quite uh, good to know about the table details, what tables we have, and what is the location of that table. If it is external table, then the database files lies somewhere else. So this is quite interesting thing to know. Now going back to the history, now this is the history. So if I trigger this command, we will find the complete detail about the job. What has happened over here is, if you see at the version 0, we have created the job, which was created a table, which is with the operation of create or replace. Then we wrote three different records, which came here as a write, three records. Then we updated the record. Uh, if you see here, update operations happen over here. When we updated the name of the record based on the ID, and then we deleted the record. Now, if you see here, if I find out what exactly the present state of the table is, if I do select star from the table, we have two records, right? Because we inserted three, we update, and then we remove. Now, Delta tables, we have the option of going back in time. Now, if you see here, there are versions given timestamp and all. So you can pick up any of them. You can pick up the version and all. So if I want to see what happened at the version 1, so I'll come over here. I'll write what happened. The version 1 was that only one record was inserted. What happened in version 2? At version 2, we had two records. If you see here, the second version was adding another record. And if I go with the version 3, then what happens is version 3, we had three records. So you have this option of going back in time and finding out, oh, if you have done something wrong unintentionally, uh, removed some records and all, you can go back in time and you can restore that table from that version. So that is quite interesting, which normally doesn't happen in other tools, that we can use those Parquet files, we can update, insert those operations also in those Parquet files, and then we can, in this form, we call it as Delta table in Databricks. So let's find out version 4. How does version 4 looks like? Uh, version 4 was update. So if I do this one, then the update operation happen. And if I see the version 5, then one record was removed. So you can go to any of the previous version and find out what happens. So hope I think this part is quite clear to you, but let me summarize what we did, and then we do two more important operations. One is optimize, second is vacuum. And if you want to know more about anything, just write down in the comment section about any of the topic what you're looking for. I will make a video for you. So now going back, what we have done initially, we started over here. We find out what was in our file systems. In our file system, we have one delta log. I mean, this was created once the table was created. So let me start from this point. Now here we created the table. Now the table name, this particular folder was not existing there. We saw it before. Then we inserted three records one by one. So then we find out these three records were Parquet files were created based on these three records. Then we updated the table and updated the name. This was this fourth file, which was which has the reference of updated one. And then what we did, we removed one record with the name of 33 with the ID of 333. Then it did not created any Parquet file over here for deletion because there was no need for creation of Parquet, but it created a JSON file here which actually referred that the record is no more active. And if you see here by looking at the history of the tables, we have all the operations here right from the beginning of when the table was created, what happens afterwards, and then update and delete. So this is the way you can find out how delta logging happens. And if you keep creating, inserting, and updating records, then you'll find out how to read them. But if you see in the normal scenarios, you're not going to update only 3 records. There will be like thousands, millions of records. So you'll find out that these kind of Parquet files will be huge in numbers when you play around with 500 or 1000 or a bigger data. Then the problem is how to maintain these kind of files. Maintaining all those thousands and millions of files is not a good approach. So what happens is Databricks provide one operation called optimize. Now what optimize does is if you come over here, if you write an optimize Databricks, so you'll find optimized Databricks over here. Now, what exactly Optimize does is it collects all those old files and make a one file of size of 1 GB. Now, this is the default value that can be changed if you want. There is a configuration written over here. You can change it, but maximum is not maximum. The default is 1 GB at the moment. So, what happens is when you run optimize, then all these old files will be clubbed into one file, which actually is good for performance because when we select star from a table, then it doesn't have to read all those Parquets, but it will read one Parquet file which has all the information over here. So this is the help for optimize. If you want, you can go through this. You can see the parameters and you can play around with this one, but let me run this one over here to show you what happens over here. Now at this moment we have 1 2 3 4 files over here and the 5.json. Now after running this one, what will happen is a consolidated file will be created over here which will have the data for all the files, and a new JSON will be created. Now let me do that. Now, what happens is we have optimized the table, which means basically it will club all the information into one Parquet file. Now, this is the one which has all the information. These ones actually are a kind of obsolete files now, which I'll tell you what we should do with these fun files. Now, we have a new JSON got created with this 6.json. Now let's go back to our JSON reader command, which was on the top, and let's find out what this file says. So now it has nullified all those above files, and it has created one big file which has the records which were active records now, which were because we had created 3 records, then we updated one, and then we removed one. So if you see here stats, it has value of 111 and 222, but the 333 one which we had removed is out of scope now. So if you see here, delete operations of 333 was performed. So this particular file, what it did, it scans this optimize operation scans the logs and finds out which one are the active ones, because we had removed one record also which was 333. So after collecting all those information from the files, it created a big over here which has the information about all those active files, and on all older files have become obsolete now. Now, if you see here, if I see if I execute this history command again, because we had this delete operation, the last one, but now as we have run optimize, so there will be another entry of optimize over here, which is now here. So what optimize did, it collects all this information, and in our case, we don't have 1 GB of data, but in production scenarios when we have that kind of huge data, then it will collect all that smaller files, will make a bigger file, which is actually brilliant for the performance of Databricks queries. Now, if I execute this command again, this will show me the latest state, which is 5. Now, which version 6 is for optimize. So optimize also will give me the latest one, which is, sorry, as of 6. So if I click this one, I will get only those records which are active. Now this happens when you optimize it. So if you see here, after optimizing it, those files are still existing over there. Those are not gone. Those are still existing. So what happens is that we don't need those files, but still we need to go back in time sometimes that if something bad has happened and I want to restore the table on a different version, so I can do that. So these files will be there for some time in case you want to go back in time, but these can also be removed with a command called vacuum. Now if I go here, if I write vacuum data bricks. Now, vacuum data bricks, if you read this one, what happens is it's recursively vacuum directories associated with Delta table. Vacuum remove all files from table directory that are not managed by Delta, as well as data files that are no longer in the latest state of the transaction log. Now, these are not in the latest state now. Only this particular file is the latest one, which we have clubbed after triggering the optimize command. So this is the way the vacuum is used to remove those ones which are older. Now, if I run any kind of a vacuum command over here, it may not run because in my table, I don't have anything older than 168 hours, which is recommended by Databricks. So if I trigger this command now, it says it's error in SQL because it will not trigger. Why it will not trigger? Because minimum hours it wants is 168 here. So if I do 168 hours, it will run. It will not do anything. The reason is because there is no files, because we created this file just now. If it had been older with 168 hours, it would have delete. So if you don't want to delete the files and if you want to see how these files look like, then you can just write dry run. In dry run, it will show you on your console that these are the files due for deletion, but it will not delete them. So dry run is a good command if you're not quite sure which files are going to delete, so you can use this one. So what we have learned so far is we can create delta table, delta log, how to read the delta logs for that delta table. And if we have huge number of files available, then what to do with that? We can run optimize command to club everything, and then we can run vacuum command to remove those files which are now obsolete. But as it the if you see here, if I give 0 here, that I'll get the error that I should not be go less than 168 hours. So there is no option of removing everything 0 with 0 hours, because 0 hours will delete everything from your database, and if you want to recover it, there is no way you can recover. So minimum is 168, but basically in some scenarios people go from 7 to 15 days, but it depends on your project requirement. So this is the whole scenario here. Now, this is a good approach when you want to uh, just learn how this delta table looks like, what these delta logs are. And the best part of this delta table, delta log is because when we use external location, then we can restore this whole information again if we by chance drop the table. As if you see here, if I go down, if I describe the table, extend it, and the table is, see here, it shows me external and the location is over here. Now in this scenario, there is one best thing is that if someone has dropped the table, if I now remove this particular table, now what will happen? I will still be able to restore the data, or I can create a new table based on the data which is already existing over there. I'll show you how you can do that. Now if you drop this table, this is gone. History is also gone for this table because the table has been dropped. But if you see here, if I refresh this location, the data files are still existing there. Data files are intact. There is no problem with the data file. Now, if you want to read those data files, you can use this command of select star from Delta and the location of your table. Now, if I execute this command, if you see here, the table was removed. There is no table now with this name, but the data is still existing in the delta logs. In the delta log, the logging of information is there, but in the delta table, all these Parquet files are still existing. So once you have this data, then you can also create this new table by using this command. So if I want to restore everything what was in the files, I can just recreate the table. And now this table has been created with the data over here. Now if I want to read this table here, then I can see the records. I brought it back to live. Now I have a table to play around with. So suppose if someone drops the data or something bad has happened, then this is the best part of external table, that you can restore every data back and you can create a view or a table on top of it. I hope you have enjoyed the lesson, but if you want me to make videos on some other topics, then please feel free to write in the comment section. I will also give details of all these playlists I have created. So if you want to learn more about Databricks starting from the basics one, then please go on. Thanks for watching the video. Please like and subscribe.